Hey everybody, welcome back to the channel. My name's Jake. In this video, we're going to be discussing Neovim's built-in language support using their LSP config plugin. Now, this is something that's supported in Neovim natively as of version 0.5.0, and at time of recording this video, we're on 0.6. Version 0.6 of Neovim. So there is some configuration required, and a lot of people have been asking on previous Neovim videos how to get started with language support. So that's what we're going to be discussing in this video. Now, in front of me, I have an article I wrote a few months ago about getting started with Vim. It's really just like a walkthrough of Neovim and setting up different plugins. There is a section that you can get to in the table of contents called language support. And in this section, I outline, very briefly how to get started with LSP. And we're going to stick to this in visual format here, but I assume that if you're watching this video, you already understand what the language server protocol is. If you don't, I'll give you a quick 30-second breakdown. So modern text editors like VS Code, they have support for something called LSP, which is Language Server Protocol. Now, the Language Server Protocol has been created by Microsoft, and it is a standard that allows language tools that are developed by plugin authors to support all the text editors that support the LSP, or the Language Server Protocol. Before the Language Server Protocol, we had something like this, where every language tool had to support every text editor, and this was difficult. So you had, a plugin author who wrote a language tool for JavaScript that needed to rework the tool so that it works in VS Code, in Atom, and Vim, and the list goes on for, every text editor. But with LSP, now the language tool just has to support the protocol, and as long as the text editor also supports the protocol, then instead of one-to-many, it's basically like a one-to-one. So as of version 0.5, Neovim supports this LSP, so any language tool that works with VS Code and Atom and other text editors and IDEs can integrate with Neovim. Unfortunately, it's not out of the box, right? So VS Code for some languages, it's just right out of the box, JavaScript and TypeScript. And then for other languages that are not out of the box, you can install plugins. That doesn't work in Neovim. You have to configure everything from the ground up. So that's what this video is going to be about. Before we get started, I do want to touch on a plugin that's been around a lot longer than I've been in this ecosystem, and it's called coc.nvim, which stands for Conquer of Completion. And this is a very popular plugin. It's a one plugin install, and then you can manage your language servers within, but it gives you a lot out of the box. And it's totally, I've used it a little bit, not a lot, so don't take my word for it. But I've heard great things that you get a lot out of the box without having to configure too much. The route we're going to take in this video is the built-in LSP, which in my opinion requires a lot more configuration. But as I've stated in previous videos, I like to stick to the native side of things if possible. So that's what we're going to do. Now, the first thing we need to do to get started is to install the nvim-lspconfig plugin. So this is the GitHub repository for the plugin. I'll link it in the description. But if you scroll down, you can read a ton of stuff here about what this plugin supports. But what we want is this right here. So we are using Vim plug to manage all of our plugins. And I'm going to copy this. I believe that, yep, give me that. And I'm going to go to the terminal. I'm in my .config/nvim folder here, and I can list out the directory contents. And so we want to open up our init.vim file. And in the plugins section, again, this is a file we've been building on over the last couple of videos. So if you are just stepping into this video for the first time without seeing the others, you may not have all of the context. So I'll link the other videos in the description as well. But I'm going to put this plug Neovim nvim-lspconfig line right here below some of the other plugins that we have. I'm going to save the file, and I'm going to source it with the SO. Let me zoom in a little bit here. In the bottom left of the screen, we have SO for source, and the % basically means source this current file. We'll do that, and then I'm going to plug install. Now, just a quick refresher. When you use Vim plug to manage plugins, it exposes some of these commands that you see on the bottom left. You can sift through them with tab and shift tab. and the one we want is plug install. So entering this will open up a buffer on the left, and it will install nvim-lspconfig. I already had it installed, so I'm going to quit that out, and I'm going to save this file. So the next thing we need to do is to install a language server. So part one is to actually install the nvim-lspconfig plugin, which we just did. And the second part is to install one or more language servers depending on your use case. Now this is going to be relative to you. I'm going to use TypeScript as an example. I use TypeScript every single day, so having that language server installed is a big bonus. But what is required is not something that you will find in most Neovim configurations, because this happens outside of Neovim. You are not installing a plugin to get a language server running. I just want to make that clear, and I think I've stated it in this article. When you install a language server, you are not installing it as a Neovim plugin. You are installing it as like a global package on your computer. Now there's a ton of package managers that do this, and if you go to the nvim-lspconfig repository, there is a section or a markdown file called server configurations, and if you open that up, there's a huge list and a massive list of all the language servers that you can install depending on your language. So, you know, just briefly looking at this, there's a language server for Angular, for Bash, for C, for Clojure. CSS has one, Dart, you know, there's a ton of them. Docker has one. So whatever your use case is, you're going to want to come to this list, find the language that you want to support, and install the server. So I know that for TypeScript, I want TS server. And so if I click this link, it'll bring me to the TS server section, and this is going to walk me through installing the particular language server. So, you know, for TS server, you can install it with npm, but that's not the status quo for all of these language servers. Some may be installed completely, you know, in a different way. But for TypeScript, I need to install TypeScript and TypeScript language server globally. So I'm going to copy that. Now, I believe I already have this installed because of previous test runs, but if I just go npm install -g is the global flag, and I'm going to be installing two packages here, TypeScript and TypeScript language server. Okay, now this is installing these packages globally. So npm, you know, node package manager, depending on how you have node set up, will dictate where these packages are installed. I'm using, this is a little sidebar, but I'm using a tool called nvim. And so if I say, you know, which node, it's going to point to this nvim directory where the node binary is installed. But that is beside the point. I do have my language server installed, and the next step is to configure it. So let's hop back into the Neovim nvim-lspconfig repository. So a quick refresher, we installed this plugin, we installed our language server, and the next step is to kind of configure lspconfig to work with the language server or servers that you've installed. Since we've only installed one, we'd really only need to do something like this. Now, the example they use in their quick start section is Pyrite. And Pyrite is a language server for Python, which can also be installed with npm. So you see here they're installing the language server, and then in a Lua file, they are requiring lspconfig plugin, and they're attaching this setup function to a Pyrite language server, you know, property. I guess I'm not a huge Lua nerd here, but so we want to do this for TS server. Now, in the previous video, we created a Lua directory with a namespace directory inside of it. So if I go into the Lua directory and I list out its contents, you will see this this folder named after my GitHub handle, and I can go into that. Let me clear out the terminal, and I'll list out the contents here. And you see I have a few things. So I have init.lua, telescope.lua, and this test.ts file. So .ts is a TypeScript file type. This we're going to be using to kind of, visualize how these language servers attach to buffers depending on the file type. Telescope.lua we worked with in a previous video, and init.lua is sort of the index of this namespace directory. So, again, if you haven't seen the previous video on Lua and namespace directories, you might feel a little lost here, but just a quick primer. Anytime we want to configure plugins in Lua, there are a number of ways to do this within Vim and Neovim. There is sort of a folder structure that you can abide by, but I prefer to use this Lua namespace directory to hold all of my plugins. I may not always feel that way, but at the present moment I do. So what I do is I create a Lua directory inside of the nvim directory, and then I create a namespace directory inside of the Lua directory. And all of my plugin configurations go into their own file. So Telescope is a plugin and its configuration is in this telescope.lua file. And then init.lua requires them. So if I cat out init.lua, you can see that all it's doing is requiring the telescope configuration. Now I want to create a new Lua file in this directory called lspconfig.lua. And inside this file, I want to do something similar to what the documentation is doing. I want to take this right here and I'm going to paste that in. And instead of Pyrite, I'm not using Pyrite, I'm using TS server. So I'm going to do that. And I like to format my Lua require statements like this. Both are valid. And that's pretty much it. This is all that's required to get your language server set up. So I'm going to save this file, and the next step would be to require this LSP config inside of init.lua. And once I do that, TS server will start attaching to TypeScript buffers. So we have this test.ts file that I've been foreshadowing, and I'm going to use it as an example of what happens when a language server is installed but not attached to a buffer, and then the inverse when it is attached. So right now we have a lspconfig.lua file. We've done the bare bones configuration for TS server, but we have not required this file inside of init.lua. So essentially, Neovim doesn't know it exists. So I'm going to open up test.ts within Neovim, and it's a basic file. I have a hello world string, and I'm logging out a variable that doesn't exist, but there's no language support here. There's no diagnostics or anything like that. Now, when you install LSP config, you gain access to a couple of commands that you can see on the bottom left, similar to vim plug. So one of those commands is LSP info. If I click LSP info, you're going to see that the detected file type is TypeScript, but the servers list, or the servers that have attached to this buffer, is empty. Now, this is obviously not what we want. We want TS server to attach to this buffer and start providing that language support. I'm going to bow out of this file, and I'm going to go into init.lua. And below our require statement for Telescope, I'm going to require LSP config, which is basically just requiring that LSP config.lua file. I'll save that, and I'm going to go back into the test.ts file. And two things to note. So the first thing to note is this message on the bottom. It says, and in brackets, it says LSP config. So this message is being emitted by the LSP config plugin. And it says auto start for TS server failed, matching root directory not detected. We'll get back to that. But let's run LSP info again. And you can see that the detected file type is still TypeScript. And we have a TS server configuration here. So something's happening, right? TS server is running. It acknowledges that we're in a TypeScript file, and it it's showing itself, but nothing's working. And the reason for this is something, it didn't make sense to me at first until you check out the GitHub documentation for LSP config. So there's a section right after installing the language server and configuring it that's called automatically launching language servers. This section describes how a language server will identify your root directory. And the root directory is important because it allows the language server to provide features and support across your entire project, not just in the file that you're in. So depending on the language server will depend on how it identifies your root directory. In this example, Pywrite, if you are using Pywrite as a language server and your current buffer is a Python file, then the Pywrite language server will start to walk through your current directory and any parent directories and look for a couple of files that match a particular pattern. In this case, it looks for .git, which I believe is a directory. It looks for setup.py, setup.cfg, and so on and so on. If it finds any of these files in a directory, then it will effectively label that directory as your root, and then it will start providing language support. For TS Server, this is a little bit different. If I go back to that server configurations list and you go into the TS Server section, there is a section here that defines the patterns for TS Server. So if TS Server is attached to your current buffer and it starts inspecting your directory, if it finds package.json, a tsconfig or jsconfig.json, or a .git directory, then it will say, hey, whatever directory that is, this is your root. Now, why is this important? Well, you want to know the root directory because, in our case, we're using a test file, and in your case, you might be in like a full-on project, right? You might be working for your company or maybe a side project, and you have a massive application with many directories, many files, and you want language support across the entire project. You don't just want it within your file. If you're importing and export from another file, you want your language server to know that it exists. You want your language server to tell you what you can import. You want auto completion, all of these things. Because this test.ts file is just in some random directory, which has no .git folder, it has no package.json or tsconfig or jsconfig. It doesn't have any of those things, and so Neovim, or should I say the LSP config, is confused as to where to start scanning your project. But I can show you that all you need to do is create one. So if I run git init will basically initialize this namespace directory as a git project. And now I go inside of test.ts. There is no more message here, and all of a sudden I'm getting some diagnostics. I have an error on line 3, and it says cannot find name string 2. Did you mean string? So this is really helpful. Now, this is just purely example's sake. This test.ts file is not supposed to exist here. I just kind of did it as an example. Neither do I want the .git directory in there, but essentially you hopefully get the idea. If you install language server and configure it properly, you may not see anything working unless you are in a specific project that has those root directory patterns being matched. Okay, so we have a basic understanding of how language servers are installed and minimal representation of those configurations. But we want to expand on that configuration because right now it's really not doing anything. So I'm going to open up lspconfig.lua, and the first thing I want to do is help our future self. So most likely, if you're doing any substantial work in this field, you're going to be working with more than one language. Maybe that's JavaScript and TypeScript, maybe it's HTML, CSS, Python, whatever. And this one-liner here is really only helpful for one language server. What we want to do is create some sort of script that will map over any language server we want and set up our configuration. Now, some language servers might have different requirements, but for the most part, you're going to find that a lot of your configuration can be applied to every language server. So what we'll do is we're going to create a local variable called nvim-lsp, and we're going to set it equal to the require statement. So essentially you can just do something like this, right? It's really the same thing, but we want to go a step further. I'm going to create a local variable called servers, and I'm going to set it equal to a Lua table. And I'm going to add TS server, but maybe I work with Python, so maybe I'll use pywrite, maybe I use clang D. The thing to take away here is that your server's table can be added to, removed over time. You don't have to create these, individual setup functions for each server. So I'm going to remove all this stuff here, and we're still just using TS server, but in the future we could add to this table. And we're going to use a Lua paradigm here called a stateless iterator. Stateless iterator is very similar to a for loop in JavaScript if you're familiar. You have your table here, and then you can iterate through that table and get the index and the value of each item. What we are concerned with is the value. So in the first loop of this iteration, or in the first iteration of this for loop, we'll get I guess I is equal to 0, or maybe it's 1. I don't know what Lua's indexing is like, but I don't really care about the index. And we'll get the value. So value would be 1, and then it would be 2, and then it would be 3. So similar to that example, we can create our own little loop here. And so I'm using an underscore rather than an index because we're not really using the index. And then we're going to set the value on each iteration equal to this local LSP variable. And we're going to loop through this server's table. So what essentially we're doing here is saying, okay, for every server or should I say every server name in our server's table, set the server name equal to LSP, and then we want to do something with that. And the thing we want to do is essentially what we were doing before. So if you remember before, we were requiring LSP config, and then we were adding a TS server property, and then adding a setup property, and doing this, little open bracket, close bracket stuff. We want to do something similar. So we're going to say nvim-lsp. We're not requiring it anymore. We can just use the local variable, and we will create an item in this nvim-lsp. I'm assuming it's a table or an object of something of that sort. And then we're going to add the name of our server in the iteration. So in the first iteration, the LSP variable will be equal to TS server. In the second iteration, it could be pywrite, so on and so on. Right now, obviously, we only have TS server. And then dot setup, open bracket, close bracket. So this is the same exact thing as doing this. So this one-liner here is the same as doing this, right? The reason we're doing this is instead of, maybe in the future you wanted to add pywrite, you could absolutely do this, right? And maybe you're going to work with clang D. So you can do, that's not right. Clang D dot setup. This is totally valid. You can do that rather than doing something like this. Both examples will result in the same nvim-lsp table, but eventually we're going to add configuration here. We're going to add config here. I think in Lua it's only 2 dashes. And a lot of this configuration is going to be the same. So this is the same. And, samer. So all this stuff is going to be the same, so why duplicate when we can just create one little stateless iteration, loop through our servers, and set them all up equally. And that's exactly what we're going to do. So I'll delete those. I'll delete this cheeky little comment, and I will save that. And we can go back into, well, we don't have, I deleted that test TS, but let's create it. Auto start is failing. That's that's because we don't have a Git directory. But let's do this. Let's git init and then vim test.ts, and then we'll try to print something that doesn't exist. And it's still working, right? Great. And let's go back into lspconfig.lua. So essentially we have the same thing here, but now we're kind of doing it in a nicer way. Now this still might not make a lot of sense to some of you. You may be asking, well, why are you adding so many more lines of code when the one line would do? And I guess the best way to illustrate this would be to use some of the special functions that can be included in this setup property here. So Neovim has a special onAttach function, and I believe you can find it in the documentation. So this onAttach function, it will allow a language server to do things when the language server attaches to your current buffer. So if I have TS server installed and I enter into a TypeScript file, then TS server will abide by this onAttach. It'll attach to the current buffer, and then anything defined in this onAttach function will occur. So you can see in the GitHub repository, the examples given, it says use an onAttach function to only map the following keys after the language server attaches to the current buffer. So what's really helpful here is you can define key maps, and anytime your language server attaches to the buffer, these key maps will be useful. So you can probably guess now why we want to do this. We wouldn't want to define an onAttach function for every language server. We just want to define it once. It doesn't matter if I'm in a TypeScript file or a Python file. I want my key maps to remain the same. So let me delete this. So I'm going to create a local onAttach variable inside of our LSP config file, and it's going to be equal to a function, and I'm going to define this above our for loop. And this function receives two arguments. It receives the client and this buffnr. Now I'm not sure what buffnr stands for, so I'll go into the help manual. The result is the number of a buffer as it is displayed by the ls command. Okay, so this function can then be passed to each language server like so. And what we do in this onAttach function, well, it's really up to you. I personally kind of stick with the documentation, and I've defined most of my key maps. In fact, I'm pretty certain I just copied straight from the documentation and placed all of this in my LSP config. So let me pull up my LSP config here. So this is my onAttach function. I'm creating a local function inside just to make the key maps, the syntax a little cleaner. In fact, I'm pretty certain that Neovim's doing the same thing. So there's a local function called buffSetKeyMap that kind of simplifies the syntax a little bit. So let's just straight up, actually let's copy from mine. I'm gonna take all of this, and we're not gonna worry about this right now. I'll copy that, and I'm gonna dump it right here. So what we have now is we have an onAttach function that itself defines a function within called buffSetKeyMap, and it just simplifies the syntax of defining a key map. And so you see a lot of these key maps are occurring in normal mode. That's what the N's for. And this is the key map itself. So if I type G over any text in a TypeScript file or whatever other server I've defined, maybe a Python file up here, then the following command will be executed. So in this case, G will execute this declaration. Essentially, it's like goes to the declaration of whatever text or variable I'm over. So to really see this in action, let's go ahead and save it. And these options right here, no remap and silent equals true, they all get passed to every key map. So that simplifies things a bit. And each server that we defined in our servers table will receive this onAttach function. So that's really the benefit of doing that. And there's a bunch of other things that you can place inside of the setup function too, that you can check out yourself, and we're going to touch on a few of them. So I'm going to exit this file, make sure I save it, and we're going to test out some of these key bindings. And I'm going to go in this. Obviously, we have our error here because string 2 is not a thing, but let's create it. We'll say string 2 equals hello YouTube's. And now let me save that. If I hover over string 2 and I use my GD key map, you'll see that the cursor jumps to string 2 variable where it was defined. And this is really helpful. And if you are using, let's just say, you import string 3 from some file. Obviously this doesn't exist, but let's just say it did, and I GD onto string 3. Let's say this is now string 3, and I go GD. Instead of jumping here, it would go to wherever string 3 is defined in another file. Obviously, you need to be in a project. The root directory needs to be defined, but you can start to see that you're getting a lot of the benefits that modern text editors like VS Code provide you. It looks a little ugly right now. There's no we haven't really done much about styling our diagnostics, but that's for another video. But you can start to see some of this coming together. There's a few other really helpful key maps that we can kind of take advantage of here. One of them that I really like is this hover key map. So if I type capital K on a variable, it will give me that hover window that you see so often inside of VS Code that will tell me a little bit about what the variable is. So let me hop into test.ts. I'm just going to delete all this. I'll make an interface called props, and we'll say, on click, just, maybe it receives an ID that's a string, right? And then we'll create a function, my component, that gets props that are defined as props, and let's just print that out, right? Print props and return hello world. So I'll save that. And now if I hover over props and I do that command K, so I get like a small little window that tells me this props is a parameter and it's of type props. And if I were to maybe console.log the onClick props.onClick, let's save that, and then I do command K, it tells me the exact type of props.onClick, which is really cool. Now VS Code does this by hovering, and I know that you can get that as well. Maybe you have your cursor over on click for a certain amount of time and then the window shows, but you can start to see the power coming through. Before we move on, I do want to address the text vomit that I dumped into this function. If this is really confusing to you, I do have a whole bunch of information on what it's actually doing in the getting started with Vim blog post that I wrote. So just go to language support and you can go to language servers, scroll down a little bit, and then I kind of walk through this onAttach function, and we start with just one remap, and then I explain the syntax and kind of break it down for you. I know it's a lot. Just trust that it does come from the GitHub documentation. This isn't something that I did myself. Again, try to stick to conventions where you can. And this file or this blog post will help you to understand how all of this is working. Great, so we got a basic setup for language support going on. We have our LSP config Lua file. It's being required in our main configuration. We've set ourselves up for future success by allowing us to configure multiple servers at once, and we have some basic key maps. In the next video, we're going to take things up a level because there's still a lot of functionality that we don't have, mainly auto-completion. Now, auto-completion is a completely different beast that requires a lot of plugins, and I think it deserves its own video. So if you're interested in that, stay tuned, but I hope at least you understand the basics of getting the built-in LSP set up for Neovim. Let me know your thoughts in the comments below. I hope you learned something. And again, we're going to be diving into language support a lot because it's still something that I want to fine tune in my own setup. So yeah, we'll see you on the next video.